Okay, this lesson we're gonna kind of consolidate our understanding of operations with algebraic vectors for sure, but also I wanted to start off the lesson by determining whether expression involving vectors is a vector, a scalar, a number, or it's actually meaningless. So it's important, especially when you're doing vector algebra, to be able to predict whether your answer should be a vector or a number. So we're going to look at how we would decide whether vector u plus vector 3w was a vector, a scalar, or it doesn't have any meaning. So the easiest way I'd look at here, I'm adding, it's a vector plus another vector. And when you add two vectors together, you get a vector. So this expression is a vector. Here we have A dotted with B plus C. So we know we have a vector, vector A, and we're dotting it with the vector B plus C. When you add two vectors, you get a vector. And when you do the dot product of two vectors, the dot product of two vectors is a scalar. So u plus 3w is a vector, A dot B plus C is a scalar, or a number. This, we don't have magnitude bars, so this is a vector projection of A on B, so we know by definition that that's a vector. Here we have two vectors, x dot y, so we know the dot product of two vectors is a scalar, and we're adding the dot product of two different vectors, or one of the same and a different one, which is another scalar. And when we add two scalars together, we get a scalar, or a number. Here we've got the cross product of two vectors, which we know is a vector, perpendicular to both of them. And we're subtracting 2 times vector w, which is also a vector. And we know when we subtract two vectors, we get a vector. Here we have A cross B minus C. So if we look at this part first, this is the cross product. So we have a vector crossed with B minus C. So when you subtract two vectors, you get another vector. And we're dotting it with another vector. 2 times vector C is a vector. And we know that vector crossed with a vector is a vector. Dotted with another vector, when we dot two vectors together, we get a scalar, because the dot product is a scalar. So that's how you would go about determining whether an expression resulted in a vector, a scalar, or meaningless. Meaningless would be something like if you had for instance, let's say two vector u's crossed with vector b dot c. Okay, so the brackets say I have to do the dot product first, so that would be a vector crossed with a scalar, because when you do the dot product of two vectors, you get a scalar, and that's impossible. You can't cross a vector with a number. You can only do the cross product of two vectors, so this would be an example of something meaningless. All right, so our next example, so this is where we're going to kind of consolidate all the different operations we've learned how to do with vectors. So we've got vector u given to us, vector v given to us, vector w given to us, and we're going to change it to an ordered triple. And then we're going to find each of these. So vector 3u minus 4v plus w. So again, I'm looking at this and I know my answer is going to be a vector because I'm adding and subtracting scalar multiples of vectors. Showing my work here, vector 3u is going to be 12, 6, negative 6, minus vector 4v is going to be vector 4, 12, 20, plus vector w, which is negative 7, 6, negative 1. And then I'm going to do my calculations here. So I'm doing 12 minus 4 plus negative 7 gives me 1. 6 minus 12 plus 6 gives me 0. And negative 6 minus 20 plus negative 1 gives me negative 27. And my answer is a vector represented by an ordered triple there. Done. Okay, u dot v. So vector u dotted with vector v. So that's multiply and add, and my answer should be a number. So that's going to be 4 plus 6 minus 10, which is 0, which actually means u is perpendicular to v, but my answer is a number, which I predict because I was doing the dot product of two vectors. V cross w, so we're taking vector v, which is 1, 3, 5. Order matters when you're doing the cross product, and crossing it with vector w, which is negative 7, 6, negative 1. And we're going to get a vector with 3 components. We know a cross product gives us a vector, and kind of our little shortcut method for doing it. So here's vector v, 1, 3, 5, repeat the 1. Vector w, negative 7, 6, negative 1, repeat the negative 7. Start here and cross. So the first component is going to be negative 3, subtract 30. The second component is going to be negative 35, subtract negative 1. And the third component is going to be positive 6, subtract negative 21, which is going to give us negative 33, negative 34, positive 27. So that's vector v cross w. Now we have the projection of u onto w, so that has a formula as well, and we know our answer should be a vector. So it's going to be u, the little one does all the work, u dot w over the magnitude of w squared times vector w. So u dotted with w over the magnitude of w squared. So the magnitude of w is going to be 49 plus 36 plus 1, the square root of 86, but we're squaring that, times vector w. So then we're doing the dot product here of u and w, so that's going to give us negative 28 plus 12 plus 2 over 86 times negative 7, 6, negative 1. So that's going to give us negative 28 plus 14, so negative 14 over 86 times negative 7, 6, negative 1. Reduce this, so negative 7 over 43 times negative 7, 6, negative 1, which ends up giving us 49 over 43, negative 42 over 43, positive 7 over 43. And that's a vector expressed as an ordered triple there. So the next question wants us to find the angle between u and w. We can call that angle theta if we want. We know we always use dot product to do that. So the cos of theta is going to be u dot w over the magnitude of vector u times the magnitude of vector w. So vector u was 4, 2, negative 2, dotted with vector w, which was negative 7, 6, negative 1. The magnitude of vector u, so that's going to be the square root of 16 plus 4 for 24. And the magnitude of vector w is going to be the square root of 49 plus 36 plus 1, which is 86. So the cos of theta is going to be, so dot product, multiply and add, negative 28 plus 12 plus 2 over the square root of 24 times 86, which is 2064. So the cos of theta is going to be negative 14 over the square root of 2064. Theta is going to be the cos inverse of that. Or approximately, make sure you're in degrees, 108 degrees. So 107.9, but I'll do approximately 108 degrees. Okay, this one says the magnitude of vector w plus 2v. So that our answer is going to be a number because we know it's a magnitude. And then the magnitude of vector w, which was negative 7, 6, negative 1, plus 2 vector v's. So that's going to be vector v multiplied by 2. So 2, 6, 10, which is the magnitude of vector, so negative 7 plus 2 is negative 5, 12, 9. You want the magnitude of that vector, so that's going to be the square root of 5 squared plus 12 squared plus 9 squared, which is the square root of 250. So that's our answer is a number, magnitude of that, the sum of those vectors. U hat, we know U hat is going to be vector U divided by its magnitude, and vector U is 4, 2, negative 2, and its magnitude would be the square root of 24. So vector U hat is going to be 4 over the square root of 24, 2 over the square root of 24, negative 2 over the square root of 24. And again, that's a vector. 2u, vector 2u minus w crossed with vector v. So vector 2u, so vector 2u is going to be 8, 4, negative 4. Subtract vector w, which is negative 7, 6, negative 1, crossed with vector v, which is 1, 3, 5. And I'm doing this part first because of the brackets. So then I have vector 15, 8 minus negative 7, 4 minus 6, negative 4 minus negative 1, crossed with 1, 3, 5. So I'm going to write down here lower my shortcut thing here. So 15, negative 2, negative 3, repeat 15, 1, 3, 5, repeat the 1, start here, downward product minus upward product. So that's going to give me the vector negative 10, subtract negative 9, negative 3, subtract 75, and then 45, subtract negative 2, which is going to give me negative 1, negative 78, 47 as the cross product of 2u minus w crossed with v. Then we want a unit vector perpendicular to both vector u and w. So first of all, just to find a vector perpendicular to u and w, that's the definition of the cross product. So first we're going to find u cross w. So I'm going to write out my vector u, 4, 2, negative 2, repeat the 4, and vector w. Start here. So vector u cross w is going to be negative 2, subtract negative 12, 14, subtract negative 4, 24 subtract negative 14. So vector u cross w is going to be, so that's going to be positive 10, sorry. 18 and 38. And we want to find a unit vector that is in this direction. So this u cross w is perpendicular to both u and w, but now we want a unit vector perpendicular to u and w. So for instance, if I want to call my unit vector a hat, then it's going to be vector u cross w divided by the magnitude of vector u cross w. So vector u cross w we found already over its magnitude and then so that's going to be 1,868. So a hat vector is going to be 10 over the square root of 1868, 18 over the square root of 1868, 38 over the square root of 1868. It's a vector, it's a unit vector. So if I found the magnitude of it, it would be 1, and it's perpendicular to both vectors u and w, because by definition, the cross product of two vectors is a vector perpendicular to both of them. J wants the magnitude of the projection of u onto w. So that's the magnitude of u dot w over the magnitude of vector w. So that's going to be the magnitude of u, which is 4, 2, negative 2, dotted with w, which is negative 7, 6, negative 1, over the magnitude of vector w, which is going to be the square root of 49 plus 36 plus 1, or 86. So then dot product, magnitude of the dot product, so that's negative 28 plus 12 plus 2 over the square root of 86. So that's going to give me the magnitude of negative 14 over the square root of 86. So the magnitude of negative 14 is positive 14, or the absolute value of negative 14 is positive 14 over the root of 86. So that is the magnitude of the projection exactly. This is exact. If you want to get it approximately, you can use your calculator and do 14 divided by the square root of 86. And it's approximately 1.5 units long. So that's the length of the projection of u on w. And then we have 2u, vector 2u minus v dotted with vector w. So vector 2u, so I'm multiplying the components of vector u by 2, so that's going to give me 8, 4, negative 4, subtracting vector v. And I'm dotting that with vector w. So, and when I subtract these two vectors, I'm going to get vector 7, 1, negative 9, dotted with vector negative 7, 6, negative 1. Dot product, multiply and add, so negative 49 plus 6 plus 9 gives us negative 44, I believe. Nope, negative 34. And that is the end of this lesson. Just consolidating your skills with all of the different vector operations that we've learned.